Okay, we have the equation y double prime plus 5y prime plus 6y equals tangent t. We let y1 and y2 be solutions of the homogeneous equation, the equation we get if we replace tangent t with 0. And of course the homogeneous equation is very easy to solve. And then we assume, well, we don't assume, we actually can prove that their particular solution would be u1 y1 plus u2 y2. Kind of a linear combination of y1 and y2, but with, instead of constant numbers out here, functions, u1 and u2, being functions of t. This is a particular solution for reasons that you don't worry about right now. I'm just, we're just looking at the method here. We'll talk about the how method of undetermined coefficients and so forth, or reduction of order, leads us to a solution, leads us to this conclusion. But we're just going to use the conclusion because most people just do this. Okay, most people don't remember how it all came about. Some people will do better if they know where it came about and can reconstruct it anytime they need it. The whole thing is that this is going to work as long as u1 and u2 satisfy this matrix equation, where g of t is the function you have over here, and y1 and y2 are the solutions of the homogeneous equation. So that's it. Okay, all I have to do is write this matrix down and solve the equation. First, you've got to find your solutions to the homogeneous equation. And of course, your solution is not going to give you u1 and u2. It's going to give you u1 prime and u2 prime. So you're going to have to do some integration. And it's not always possible to do that integration. You have to do some integration to find u1 and u2 after you've solved this equation. Okay, well, this equation, and I'm assuming that the linear algebra you had 18 months ago in many cases is still fresh in your mind. Well, it isn't, but I have warned you to shore up what you know about linear algebra. So most people appear to be a little rusty with that, and that's no surprise. Okay, well, we have this equation. How do we solve this equation? We solve this equation by multiplying both sides by the inverse matrix. Okay? Now, when I say y1 and y2 are solutions, I kind of misspoke. Y1 and y2 are not just solutions to the homogeneous equation. They have to be a fundamental set. Of solutions to the homogeneous equation. Okay? And that's related to the fact that you want to invert this matrix. If you don't have a fundamental set, the determinant of this matrix is going to be 0. It's not going to be invertible. If you have a fundamental set, the Wronskian is non-zero, and of course this is just a Wronskian. Or if we do the determinant of this as a Wronskian. So you would have it. Well, in any case, the inverse of this matrix is this, divided by, of course, its, I want to say magnitude, its determinant. And I'm not going to detail why that is. You invert a matrix by writing down the matrix with the identity augmented by the identity matrix, then you reduce the whole matrix so that the left-hand side becomes the identity, the right-hand side becomes the inverse. Now for 2 by 2 matrix, it can actually be simpler than that. It's just like you flip these two things here, and then you leave these where they are but make them negative. And that gives you the inverse of a 2 by 2 matrix. And I don't care if you do that, because we're probably not going to get to the 3 by 3 case, but you should be warned that if you get to the 3 by 3 case, you're going to have to do that. Okay, well, now, u1, u2 prime then will be the inverse matrix times this column matrix 0 g of t. Again, it's mysterious where all this came from. We'll talk about it. Now, our solutions to the homogeneous equation, which is very easy, we get characteristic equation r squared plus 5r plus 6, and that factors into r plus 2 times r plus 3, giving us r equals -2 and -3 as solutions, leading to y1 and y2 being e to the negative 2t, e to the negative 3t. That's our fundamental set for the homogeneous equation. Not the only possible fundamental set, but it's the simplest. So our matrix y1, y2, y1 prime, y2 prime is just what? Well, y1 and y2, e to the negative 2t, e to the negative 3t. The derivatives are negative 2, e to the negative 2t, negative 3, e to the negative 3t. The inverse, well, flip these two, and this goes here, and this goes down here, and then make these the negatives of what they are. That sounds simple, but I was kind of under the influence of allergies when I did this, and I did it wrong about 6 times. So, keep an eye on me. Okay, well, anyhow, we have this, and of course we have to divide by the determinant, which is easily found to be negative e to the negative 5t. Okay, so I did something else really kind of ignorant. So, what I was doing when I did this, and I wrote down an equal sign that doesn't belong there. I get all over people for writing down equal signs that don't belong there. This would be the matrix times the inverse. I was just verifying that the matrix multiplied by the inverse does give us the identity. And if you multiply this matrix by this matrix, of course this matrix needs to be divided by e to the negative 5t, which gives you what I have up there. But if you do this matrix times this matrix, you're going to get e to the negative 5t, negative e to the negative 5t here, negative e to the negative 5t here. This row times this column gives you negative e to the 5t. This row times this column gives you 0. This row times this column gives you 0. This row times this column gives you your negative e to the negative 5t. You divide that by the negative e to the 5t, and you get the identity matrix, showing that finally, after a couple of false starts, I did get a matrix that does multiply out to give us the identity, showing that this is the inverse. Okay. Now, I'm not rusty on this or anything. I'm just, when I did this in class, I just wasn't able to look at this and then write down the right thing here. I could look at a 5 over here and write down a 17 down here. Just allergies early morning. And a little senility maybe. Okay, so here we have the inverse. Now here's the inverse. So I just divided through by the e to the negative 5t, and I got this. Meaning then that we come back to this to find our u1 and u2 prime, u2 1 prime and u2 prime, multiply the inverse by our 0 g of t. G of t is our tangent t, so 0 g of t is our 0 tangent t. Here's the matrix. We just multiply it out. Well, this row times this column, all we get is e to the 2t tangent t. This row times this column, all we get is negative e to the 3t tangent t. So u1 prime is this, meaning that u1 is an antiderivative of e to the 2t tangent t. That's not a trivial integral. Okay, you're going to have to integrate that by parts, and you might run into some problems with it. I haven't actually integrated. I think it can be integrated. It looks like there's a clear path to doing that, but I haven't done it yet. And u2 prime, of course, is this, so that u2 is the antiderivative of that. Once you have u1 and u2, your solution to the particular solution, let's say, your solution to the specific equation is this, and you would, of course, add that to the general solution of the homogeneous equation to get the general solution of this differential equation.